already talked about the idea behind absolute value. We've even shown how to represent taking the absolute value in a piecewise manner. If you recall, I can represent, and remember, within context, we have to be able to interpret what these bars mean. They mean different things in different contexts. Right now, when we have a numerical value or an expression inside the absolute value, then I'm looking at this and I'm saying, I wonder what that x is. Is that something positive? Is it something negative? Well, that's going to allow us to define those two cases. So in the first case, where the input to the absolute value, what we're taking the absolute value, if that x, that input, is a value greater than or equal to 0, I'm going to leave it alone. I'm going to keep it as is. However, if that input is negative in value, so in this case, x is a value less than 0, does anybody remember what we do to that?
Take its negative reciprocal, or just positive reciprocal.
Oh, we're so close. We just take the opposite.
Okay, I thought
right?
there was something.
So in this case, if this is negative, we are going to take the opposite of x. And we're going to delve into why we are doing this, algebraically and geometrically. So if the input is negative, we are going to take the opposite. Those are the two cases. Now, I'm going to perhaps give you an, yes, but then you're going to have to tell me if I go outside the borders. More? Is that good?
So good.
Okay, here we go. Now remember, I don't know where it ends, so you have to tell me. All right, here I'm being asked to take the absolute value of the square root of 5 minus 13. So I've got to first identify whether this input, what's inside the absolute value, is a positive value or 0, or negative. Now I know how to estimate the square root of 5. The square root of 5 falls between what two perfect squares? 4 and 9. Okay, so the square root of 4, 2, square root of 9, 3. So square root of 5 is in between there. If I subtract 13 from that, is that going to make this input to the absolute value a positive value, or 0, or negative?
Negative.
It's going to be negative in this case. So I'm looking at case 2. So I'm going to take that square root of 5 minus 13, and I'm going to take the opposite of it, because we said that it represents case 2 where it's, less than 0. Then I'm going to distribute negative 1 times the square root of 5, negative 1 times negative 13. It's going to give me the negative square root of 5 minus a minus becomes plus 13. And that's sufficient if we don't have a calculator. Now, if I look at the next one, I look at the numerator, I look at the denominator. The numerator is just negative 7. However, in the denominator, I have an absolute value expression. So I'm looking at the input to this absolute value. And is that represent case 1 or case 2? Case 2. So what am I going to do to that value inside?
Opposite.
I'm going to take the opposite. So in the denominator, I have the opposite of the input to that absolute value. So now I need to simplify this fraction. So I have negative 7 over a positive 7, which reduces to negative 1. Yes?
Yes.
Okay. Ooh, then it starts getting even better. Look at this. Absolute values within absolute values. I'm moving up. I have the absolute value of the absolute value of negative 5 minus the absolute value of negative 13. So, just like within order of operations, I'm going to look at this grouping here, and I'm going to see if there's anything I can simplify or evaluate inside that big absolute value expression. So if I look at this first one, the absolute value of negative 5, what is that going to be? It's going to be 5. Again, the input is negative. Take the opposite of it, so this becomes 5. This is still minus. Now the absolute value of negative 13 is 13. have minus a negative. So what is going to be happening? Minus 13. But then I'm still inside the big absolute value.
Right.
So then I have the absolute value of 5 minus 13. 5 minus 13 yields what? Okay. So then I'm looking at the absolute value of negative 8, which is 8. Now you know they get even better than that.
Mhm.
Yes, of course. But before we start working with the super exciting examples, let's think about the geometric interpretation of what absolute value really is. Yes, ma'am.
So in this one, we actually went through and we did all of it in the in between, and we got 8. But in A, is that because of the square root that we couldn't solve
Yes.
it?
Well, we're not solving. This is just an expression. We're not evaluating it any further, right?
Okay.
We're not solving for any unknown value. But we couldn't go any further. We don't have a calculator. We could estimate, but that's sufficient right
Okay,
now.
so we just stopped.
That's sufficient for
But
right now.
in any other case, you would keep going like in C?
Yes.
Okay.
Yes, because I could, because I was working with integer values.
Okay.
And they combined nicely.
Okay.
Okay. Now, any other questions? No. Okay. Geometric interpretation. So I have an absolute value. I'm taking the absolute value of x minus a. So how am I going to think about that? I'm thinking about this absolute value between these two x and a values, and I'm thinking of it as the distance between those two x and a values. So when I look at the absolute value of x minus a, I'm going to read that as the distance between the difference between x and a. So if I'm looking at the absolute value of x minus 0, this is really just the absolute value of x, because subtracting 0 gives you what you started with. So that is going to represent the distance between x and 0 on the number line. So if I can somehow isolate this absolute value expression, I can kind of recall the fact that this is telling us I'm looking at the distance, and I can envision it on the number line, and instead of counting, I can represent it as an absolute value. So let's think about two numbers on the number line. I have negative 6 and I have 8. So I can draw the number line. Why not? Negative 6, I like to always see 0 as a reference point, kind of separating those positive and the negative numbers. And I'm thinking of a way to use absolute value to show the distance between these two numbers. So I'm looking from negative 6 to 8. Now I can count that. I could say, okay, negative 6 to 0, that distance is 6. 0 to 8, that's the distance of 8. So my total distance between those 2 points on the number line is what? 14. But if I wanted to represent the distance between those 2 points using absolute value, I would recall that I would represent it as x minus a, best practice that uses x minus a. X is one of the numbers, a is the other number. Subtraction is the difference between those two numbers, the distance. So I would say that this could be represented as the absolute value of negative 6 and 8. Again, we like to see the subtraction sign. That allows us to easily identify the two, dare I say, endpoints that I'm looking between to find the distance. Now, if I wanted to algebraically evaluate this, I would say, okay, negative 6 minus 8 gives me negative 14. This is case 2, where the input is negative. So I would take the opposite of negative 14, which would give me
40.
And again, that makes sense because distance is positive. So that's where it's coming from, the distance between those two numbers. That is why if it's negative on the inside of the absolute value, we have to take the opposite because distance is always positive. Okay, so how in the world would I represent the distance between negative 5 and 2 as an absolute value? The absolute value of
Negative 5 minus 2.
Exactly. Algebraically, I could graph it, but heaven forbid the order of magnitude of these numbers, huge, like 5,000 and 25,000. We're not going to count all those tick marks. No, we're going to represent it as an absolute value. We're going to perform the algebraic operation inside the absolute value. And then it's negative, so I'm going to take the opposite, and the distance between these two numbers is 7.
Scroll down.
Now, if I keep going, I'm going to introduce decimals, nothing to be afraid of. And what would the absolute value expression to represent the distance between these two numbers be?
Negative 5.4 minus negative 1.2.
Okay, and addressing the minus a minus becomes
Positive.
negative 5.4 plus 1.2. And if I add those two numbers together, what am I going to get? Negative 4.2 inside the absolute value. Case 2, I have to take the opposite because the input is negative. So the distance between those two numbers, of course, is positive 4.2. So that's the geometric interpretation. So when you think absolute value, I want you to think distance, hence positive. Now let's talk about how we solve absolute value equations. We'll first do it graphically, and then we'll do it algebraically. So I'm kind of, this is repeating myself a little bit here, because I want you to own this. Again, absolute value is the distance between two numbers, graphically on the number line. So again, if I have the absolute value of x minus 0, it's the distance between x and 0. So what if I take that absolute value expression and then now equate it to another value? A positive value, because it represents distance. Let's talk about how we can turn that algebraic equation into words. So here's a beautiful, beautiful absolute value equation. I am looking at the distance between x and a, and I'm saying it's equal to c units. So I'm telling you what the distance between those two numbers is. Again, distance, positive. So the way I like to approach these, you may have a different way, is I like to, if I'm solving for x and I'm trying to figure out, well, what values can x be that are 3 units away from my starting point on the number line 2? So yeah, I do, yes. So I'm going to look at this number here. And again, we do want to have it represented as x minus an a. So we want to have those two values being separated by subtraction so I can easily identify the two values. So the one that I know is 2. So I'm going to look at 2 on the number line. Now I'm looking for all moving it up. All values of x that are how many units away from 2? 3. So if I'm trying to figure out what values, we'll call them x, are 3 units away from 2, I need to go 3 units in one direction from 2, and I need to go 3 units in the opposite direction from 2. So if I'm starting at 2, if my a is 2, and I go 3 units to the right, what is that x value? 5. And if I go back to 2 and I go 3 units in the opposite direction, look who decides to join us. Where am I?
Negative.
Thank you. You need a packet. A packet. Oh my gosh. You're welcome. Okay, so the other x value is -1. So I've now found the 2 x values that if I were to substitute back into this equation, I'd get a true statement. So for kicks, let's go ahead and check it. So I'm going to check x equal -1, and I'm going to check x equal 5. And I'm going to substitute those x values back into the original equation and see if that's true. Well, if it's not true, you did something wrong. So -1, move it over. -1 minus 2. That's -3. Taking the absolute value, I do the opposite. Take the opposite, so that's, it's 3 at work. Yay. And now I'm going to substitute in 5 in for x. What's oh no?
Oh.
Is positive.
Yeah.
So it stays the same. It equals truth. Yay. So how would I represent the solution set? Well, we have so many different ways. You want to use set notation? I can say the set S equals the numbers, -1 and 5. And remember, sets we like to write in numerically ascending order, not repeating values.
Right.
Or I could write x equals -1 or 5. I don't care how you write it.
Oh, okay.
Your choice.
How would you OR?
Or, yeah, it's definitely, you can't be two things at the same time, right? So this isn't really the intersection union that we're accustomed to seeing when we do
What is
intervals.
solution equals?
All right, let's try a few more.
Never had a test.
Now remembering, absolute values distance is positive, but we like to look at it as the difference between two values, x and a. Would we have to maybe do anything to the absolute, inside the absolute value, this expression here, to help us better graphically represent the information given?
Yes.
How? What would we do?
Well, it's x plus 2. You make it x minus 2.
I love it. Anybody not see that? We're okay with that?
Yeah.
Okay, so where am I starting on the number line? -2. Okay, so I'm at -2, and I'm looking for all values of x that are how many units away from 2? From -2? 3. So I'm going 3 units this direction, 3 units in the opposite direction, and what are my two values of x?
Negative.
Perfect, -5 and 1. So again, the solutions, and we could check them. We won't. You can do it for kicks at home. Okay, what about the next one? What would you like to do first to that? Okay.
I'd love to do x minus -2.
Okay, so we're going to rewrite this as a difference. I like that. You don't have to, but I like it because it makes us geometrically easily identify this value. Now, it's telling us that I'm looking for all x's how many units away from -2? 0. So I'm not going anywhere.
So strange.
I'm not going anywhere. I mean, I'm going 0 I'm not going any distance. So what is my solution to this absolute value equation?
Negative.
Just -2. Right? I'm not going anywhere. I'm just here.
Oh, okay.
Doesn't that
You
not
don't do,
work
like, special
since
stuff?
you can't have a negative equal?
It's not negative, it's 0. But I
Oh,
love that
gotcha.
you're asking that because guess what problem is next?
I'm sorry.
Look at the next one. Now, do you really have to do anything if you understand what absolute value represents?
No.
No. Why? Because what should bother you here?
That's it equals a negative.
It's a negative, so it's telling you that I'm trying to find an x that if I were to substitute in here, I would be -3 units away from it.
What?
You can't ever be -3 units away from something. At least just not on the real number line. You know, there's...
No, stop.
There. But if we think about it, there is nothing to do to this one. You would write no solution. There is no value of x that I could substitute in there that would give me a distance of -3 or any negative number. See, Kaya, I knew what you were going to ask. Paris?
Did you say Kai?
I did say Kaya. It's one of those days.
I agree. This Monday.
I know.
It's creepy math, Dr.
It's
B.
I'm back to the creepy math. Bite your tongue. All right, next one. Tell me what to do.
Okay.
Okay. 4
So
apart.
Okay, I like that. A is 1/2. So we
Right.
start at 1/2.
You go 4 to
4 units to the right, 4
units.
units to the left. And you know how I love improper fractions. Can you tell me? If I'm at 1/2 and I go 4 units to the right, what is the improper fraction?
8
For
over
where?
2.
I like it.
Oh.
Yeah.
9.
You gotta get a common denominator. You love fractions. You need to be okay with fractions? Yes. Yes. If I go to the left 4 units from 1/2, where am I?
Negative 8. Negative. Wait.
-7. halves, yes.
Okay, I'm bad at doing that.
Well,
Yeah,
you
I
better
can-
get better at
Okay.
it.
Okay.
Okay, number 6. Number 6. I'm trying to figure out what value or values I can substitute in for x that would make this a true statement, keeping this in mind. And knowing what absolute value represents, distance of 3 in this case. What are my 2 values of x?
3.
Yeah, plus or minus 3. Positive 3 or negative 3. I'm at 0 and I go 3 to the right and 3 to the left. Good. Now, before you can really start investigating distances, we need to isolate the absolute value expression first. And now, yes.
Yeah, you mean
Oh,
3
I put a
instead of
0 instead of 3.
It's okay.
Thank you. Before I can, because I'll tell you right now, people get all excited. They see the right-hand side is negative, and they're like, oh, I can't do it. Well, if there's other things attached to the absolute value expression.
Treat it like a variable.
Yes. So exactly. We need to isolate this absolute value expression, stripping everything away by doing those opposite operations, and then identify the A, and then identify what that distance is. So algebraically, what would I do first?
Plus 5.
Divide.
Plus
plus
5.
I'm going to add 5 to both sides. Very good. Okay, that is going to give me 2 times the absolute value of x minus 1 equals
8.
8. Then what would I do?
Divide by 2.
Divide both sides by 2, giving me absolute value of x minus 1 equals 4. So where am I starting on the number line?
4.
No.
No.
No,
Negative 1.
1, positive 1,
Positive,
right? X
that's
minus
by
A,
negative.
positive 1. And how many units am I going to the left and the right?
4.
4 units to the right, 4 units to the left,
So.
which would give me what 2 values?
Boy.
Excellent. Now, that's great, but we're not always going to do it geometrically. We had to truly understand what we were looking at when we were looking at absolute value in terms of distance. But now, let's look at how we would just solve these absolute value equalities strictly using algebra, our skills with algebra. Now, again, this just reiterates our 2 cases, whether our input is positive or negative, or 0 for that matter. So these are our 2 cases, how we represented it piecewise. If the inside is positive, we leave it alone. So the absolute value of 2 is 2. If the input, if what we're taking the absolute value is negative, I take the opposite, which again gives me a distance of 2. So algebraically, this is what people do. But before we show the quick way to do it, we have to understand how we arrive at that quick way. It's not good enough just to memorize a process. So in this case, I'm looking at the absolute value of x minus 2 equals 3. Now, I can look at when x minus 2, the input to the absolute value, is positive or 0. Oh my goodness, the sliding in the back of the board.
Yes. Of course.
If this input is positive, we leave it alone. So we just drop the absolute value, if you will. So x minus 2 equals 3. So this is one equation I would solve. Case 2 is if this input x minus 2 is negative. If that's the case, then I don't just drop the absolute value expression. I have to take the opposite of that input to the absolute value. So these are the 2 equations algebraically that I'm going to solve to find the value or values of x that satisfy this absolute value equation. Now, this one, trick, right? What do? One step.
Add 2.
Add 2 to both sides. Oh, I have my value of x, and I could check it. Now, the other one, you could distribute the -1. You could divide both sides by -1. I'm going to go ahead and divide both sides by -1 because I'm going to show you another starting point where people like to begin to solve these equations. So in this case, I'm going to have x minus 2, and what is the right-hand side going to be?
Negative.
-3. So if I now look at these 2, I have x minus 2 equals 3. I have x minus 2 equals negative 3. Now, a lot of people start with this, drop the absolute value, and just say, oh, I have to solve it where it's equal to positive 3. I have to solve it where it's equal to negative 3. But where did that negative 3 come from? It comes from the fact that our other case has to take into consideration that this is negative. So this is how we are arriving at. Again, a lot of people, once they isolate the absolute value expression on the left, they just immediately turn it into these two and solve them. And that's fine. I just wanted you to know where it came from. It's okay if you immediately go there. So in this case, I would still add 2 to both sides, and I'd get x equal negative 1. So there are my two solutions. Let's try the same examples we solved. Yeah, of course. So again, this is just showing you that you can drop the absolute value, set it equal to the positive and the negative to the right-hand side. We get two solutions. So, looking at this, I have the absolute value of x plus 2 equals 3. We don't have to go to the trouble of turning it into subtraction, identifying a point on the number line, looking at distances. No, I can just immediately turn this to x plus 2 equals 3, or x plus 2 could equal negative 3. I would solve each of those. And get x equal 1, or x could also be negative 5.
Negative 5?
Yeah, negative 5, right?
Yeah, my bad.
Okay, what about the next one? Well, there's no, is 0 positive or negative?
Neither.
It's neither.
There's one case.
So there's only one case. The only case that is going to make this true is the additive identity. What can I add the 2 to get 0? Negative 2. That's it. Now what about the next one? It's negative distance. That's not possible.
No solution.
No solution to this. Yeah, I can't tell you how many people on those quizzes and the tests, they start doing stuff to that, and I'm like, what are they doing? Next one, I split it into two equations. X minus 1 equals 2.5, or x minus 1 could be the opposite, negative 2.5.
Scroll down.
Scrolling. In either case, I'm going to add 1 to both sides, and my two values of x are what?
Negative 1.5 and 3.5.
What about the next one? What could x equal?
Oh.
3 or negative 3, plus or minus 3. And then we did this one already algebraically. The key is you must first isolate the absolute value expression on one side of the equation. So I'm adding 5 to both sides. Then we said we divided both sides by 2. Then and only then can you look to see if the distance is positive or negative, or can you split it into the two cases? In either case, x is going to equal what two numbers?
5.
5 and negative 3. How do we feel?
Good. Good.
Good? All right. There's two people that still need to take the test, so you can't have them back, but you know you got the grades in there.
Can we look at them?
How many people are working on the bonus project?
When does it due? There's
Yeah,
Week from Wednesday.
Oh, cool.
Oh, okay.
Now, if you're not doing it, why not? Who doesn't want 10 points?
Kind of cool.
It's cool. And I'll tell you right now, we're going to revisit this project and we're going to do all sorts of regressions using different types of functions. So if you don't do it now, you're going to have to eventually do it later. So do it now. And it's 2 points.
Okay.
You crazy people. All right. You have my math lab. Lots of, my math lab.
No.
But in addition to that, I have 2 practice sheets. The answers are in the back binder. Now, why wouldn't you do this? I don't know. What are we doing Wednesday? Absolute value inequalities. So if you can't solve equalities, you're not ready for inequalities.